Hi, my name is Kishore Borra and I am a Microsoft Technology Specialist. In the design pattern series, today I am going to demonstrate to you about a very useful and simple pattern called command pattern. If you like this video, you can follow the other videos at my personal blog kborra.wordpress.com. Let's jump start. Let's look at the agenda. So we're going to learn what is a command pattern, what are various advantages of going for a command pattern. I'm going to demonstrate that I'm going to demonstrate command pattern with the help of a code sample, and at the end we are going to consolidate our learnings under summary section. Okay, so command pattern. Let's take a step back and then look at design patterns. We know that design patterns are solutions to software design problems, which we will find time and again in real world application development. And if you look at it, they're all about the patterns. The design patterns are all about reusable designs, building some reusable designs. And you know that the design patterns have been classified into three different categories, namely creational patterns, structural patterns, and behavioral patterns. And if you look at creational patterns, these are aimed at dealing with object creation mechanisms. They will help us to create objects in a manner suitable to the situation. And coming back to structural patterns, they are aimed at easing the design by identifying a simple way to realize the relationship between different entities. And then the last one, behavioral patterns, they are aimed at addressing common communications issues between different objects. And now this command pattern falls under behavioral pattern. And as for the definition given by Ganga 4, command pattern facilitates encapsulating a command request as an object, which means representing an action as an object. I repeat, it facilitates encapsulating a command request as an object. What we are essentially doing is we are encapsulating an action as an object. So as I mentioned, they fall under behavioral pattern, and they help us. By looking at the definition, we can come to a conclusion that they will help us to persist a request or an action in the form of an object. Let's say that we would like to do some cut, copy, paste and delete actions in a particular application, and so it will allow you going for if you choose to go for command pattern, and if you want to implement cut, copy, paste or delete actions in the form of an object, in the form of individual entities, then they will allow you to have each of these actions as a separate object, okay, and which we can save and then retrieve and then perform operations on the respective objects. Which means it's basically designing our commands as an objects. In a sense, we are saving actions along with data as objects. So whenever you ask yourself a question, when you are in the middle of developing an application or designing an application, just take a while and then ask a question to yourself: do you need to save the state of an object as a command? If the answer is yes, then you got to go for command pattern. And if you look at the second one, the second definition here, so the command pattern is a behavioral design pattern in which an object is used to represent and encapsulate all the information needed to call a method at a later time. Maybe straight away, if you look at these definitions, they might look a little out of place to understand. But I'm sure once you understand, once you go through the code sample, and then when we come back to this slide, then I'm sure you will get the meaning of it. That's why I'm not spending so much time on this slide, and we will go ahead. The major advantage of going for a command pattern is what it does is it will decouple the clients that execute the command from the details and dependencies of the command logic. So when you encapsulate an action as an object, it might have a lot of dependencies on the external things. So the command logic might have a lot of dependencies on the external factor, external maybe a database, maybe a file system, maybe some repository. Okay, so but what happens here is that dependency is exclusive to the command. The client is not aware of that, so that mechanism is completely decoupled from the client. That is what this point explains us. It decouples various types of clients that execute the command from the details and dependencies of the command logic. And finally, it gives the ability to persist and queue the commands for later delayed execution. The moment once you encapsulate the action as an object, and then once you persist it, it is up to you based on the nature of the application. We can always choose to queue the command, and then based on the processing speed or based on the other project requirements, we can choose to execute it at a later point of time. That is what this last point indicates. Okay. I'm taking an example of job life cycle to explain job life cycle user interface to explain this behavioral pattern called command pattern. Okay, and so what is it about? And if you look at this diagram, so you can see that there are three different types of client applications. The first one is a Windows form, and the second one is a console application, and the third one is a web application. And if you look at all three of them, you could see that now these applications, they are about maintaining a job life cycle. Like, you would want to create a job, you want to open a job, you want to edit a job, you want to clean up a job, you want to submit a job, you want to close a job, or you might want to delete a job. So now these are different actions that are associated with the job life cycle. But here the customer requirement is as such that they have three different types of client applications. They would want to they want this capability to be available over web, through a command line application, console application, through a Windows form as well. So what do we do? So we see that each one is a command. Open job is a command, edit job is a command, clean up job is a command, submit job is a command. And then you need that functionality in all three of them. Okay, so this is where you have to decouple the client application from the respective commands. This is where we need to get into writing the code using command pattern. Okay, so let's jump start and then try to understand this application. So what exactly we do here is, so if you look at let me go back to my next slide. So if you look at this, then there will be a command, and the command is implementing. So there is an iCommand interface, and that iCommand interface has an execute method, and based on the project requirements, you can go for a validate method, undo method, a redo method. Okay, or you can add any number of properties that you want. But in its simplest form, iCommand implements iCommand interface contains a method called execute. Okay, and then now you come up with your own commands. So now I have written a cleanup command. So this is our iCommand interface, and then what I did was I have written the logic of each command separately. So I have cleanup command, close job command, I have edit job command, I have open job command, okay, I have submit job command. And then what I did was I have written a class called presenter, and what this presenter class does is, the presenter class is completely aware of all the commands which are implementing the interface iCommand. So it has the list of commands that are present in your project or in your application. Okay, and you may say that right now you have 5 commands. I wanted to add a 6th command. Yes, you can do that. You can add a 6th command, and you are not violating any open close principle. There are many techniques in which inside your presenter class, maybe you can go for a Microsoft Enterprise library Unity application block, and you can list the commands in a configuration file, and the presenter class constructor would read all those commands and then prepares an array list or prepares a list of iCommand objects that are available and ready for serving. Okay, so yeah, it is very easy to do that. And then so when you say maybe if you look at the presenter class that I have here, so it has got run command, okay, and it has got a get command. So what this get command would do is it would return to the client the command that he would want from this collection. And when we say run command, on that command is going to call the execute method. And if you see, each of these methods are implementing, each of these commands are implementing execute or validate, whatever that we have defined in iCommand interface. Okay, and the client just need access to this presenter class, and then it will, based on some key, it will request the command that it is in need of, and then just fires up the execute command on that execute action on that command, and it will serve the purpose. Okay, let's look at the code and understand it in a bit with a bit clarity. Okay, so let's go here. So I have a solution. So I have a command pattern demo here, which has got a console client application, a Windows Forms client application, a web app client application. Okay, now I have defined the job lifecycle user interface in this project. Okay, so this is the project. So if you look at this, inside this I have iCommand. You see this? So I have iCommand here. So this iCommand has got an execute method. I'm also interested in having validate functionality, so that before invoking maybe close job, I would want to check whether it is eligible for close, whether the job is eligible for close. And when we wanted to call maybe submit job, I wanted to maybe check the state of that job. So I might want to do the validation before firing up the command. That's why I have validate method as well. Okay, and based on the need, you can have some other properties defined within your iCommand. And since I'm using this key in my implementation, that's why I needed this key, so I added another property called key there. Okay, so this is the iCommand. And if you look at all the commands, I have a cleanup job command, which will implement the cleanup job command will implement the interface iCommand. Okay, and so it is having key and an execute method. And when I call execute method, my business logic is just, I'm this not great business logic out there. I'm just displaying a message box showing that the job is clean. And when I call validate, I will say job is validated. And if you see cleanup job command, in its constructor, I'm setting this property as cleanup. Okay, this is my way of implementing it, and you can do it the way you want it. I will show you why I'm setting up this key. Let's go on to the next one. So you have close job command, which is implementing iCommand. So you have job is closed operation within the execute method. Job is validated for close within validate, and in its constructor I'm setting the key as close. And I have a couple of other properties as well. So same with the edit job command, it's just the same. Job is edited, job is validated for edit, and the constructor, in its constructor I'm populating the key as edit. So open job command, just the same, it's implementing iCommand. Job is open, job is validated for open. On its constructor I'm just putting the key as open. Okay, so let me close all these commands. Okay, now let's look at the presenter class. I have a presenter class as well. And if you look at this presenter class has got a list of iCommands. So I have _m commands, which is a list of iCommand, and in its constructor, in the constructor of presenter, what I'm doing is I'm adding each of these commands directly here. You may As I mentioned previously, you may choose to have a configuration file, and you can configure Microsoft Enterprise Library Unity application block, and you can write the details of these commands and the respective DLLs there, and then in the constructor you might want to write a logic to load them. Therefore, in tomorrow, even if you add a new command, it will be easy for you to just change the configuration without changing the code inside this method or inside this class. You are up and running. Okay, so this is about the presenter and presenter constructor, and by the time the constructor gets executed, presenter has got the m commands private variable has got the list of all the commands that are available in jobs user interface. And as I mentioned, there are two more commands called get command and run command. So when I say get command, I'm passing a key. So when I pass the key, and from these underscore m commands, this is a link expression, and it's, if you want to interpret it, if you want me to put it the other way, it's like, for each command in underscore m commands, if m command dot key equals to key, just return that command. I just converted that into link expression. So that is what it is, which means from any client application, you just create an instance of presenter class, which means by that, when you say presenter equals to new presenter, so you will have m commands already getting populated because of the constructor. And then once you say that the presenter instance dot get command, and if you pass a key like open, so you get open command returned back to you. And if you say close, and this method would return you the close command, and if you say submit the key as submit, it will return the submit command. That's why what I'm doing here is in the commands and the constructor of the commands, I'm populating some key values. This is my way of retrieving the respective command from the commands collection. Okay, and then the next one is run command. Okay, so this is run command. So when you say run command, what are you passing here? You are passing I command. You're passing I command object here. So if you pass a submit command and you say execute, it is going to invoke the submit commands execute method. Okay, so this is about the jobs user interface. Let's start with console application. Okay, so when you look at console application, the code is very, very simple. This nothing much code here. So what I did was just to show the usage of the command, I have written a small method here which would list the various commands that are available. Okay, so I'm just creating a new instance of the presenter class, and okay, if args.length equals to 0, means if it is called without for example, if I just do this, so I have not given any argument, so it will just show the usage and command dot readline, and it will return it. So these are the various commands, which means I can invoke this console application by passing one of these parameters. Okay, so now what I will do is I go here, I go to the bin, go to this, and I says command prompt. Okay, so I will say console application. So these are the commands. So I'll say console application.exe, and I say open. Job is open, and I say close. Job is closed. Okay, and I will say edit. Job is edited. Okay, don't think too much in terms of the logic and the way I have implemented it. So my main focus or intention is to demonstrate the abstraction of the command as such, not the implementation details. Don't give too much of a thought about the job user interface, the job lifecycle functionality. It's just taken as a vehicle to demonstrate the abstraction of this command to you. Okay, so that's it. The user interface is very simple. You have essentially 3 lines, just creating a presenter class, and then you're calling presenter dot get command and passing the argument. It will return you the command, and you are just calling presenter dot run command. by passing that command, and it would in turn the presenter class run command would execute the respective command's execute method, and which means the call would go to the execute method of the respective instance implementing the iCommand interface. Okay, so that's about the console application. Let's look at the Windows application. Okay, set a start project. This is very simple. So I have taken the reference of the job user interface now, and then if you look at the code, nothing in the, so I have if you look at the designer, I added a tool strip here, and I added a bunch of commands here, and for each command what I did was I've given the tag name as the key, because I will be using this when somebody clicks on open job, it comes along with this tag having value as open, which I will be passing to the presenter class get command for me to fetch the respective command. So same with edit, same with cleanup, okay, so on and so forth. And when you look at the code, it's very simple. When you click on that on the tool strip, so it is going to so when we click on the tool strip on the form, so we create an instance of presenter, and then we call get command, and from the sender we are getting the tag, we are extracting the tag and passing it as an input parameter to get command, and then it will return the respective command to us. And then when we will go ahead and call run command by passing that command. So if I run this, so open job is open, I did job, clean up job, so on and so forth. So which means now here we have now seen two different types of applications, but whereas because we have encapsulated the actions as objects, so they remain one and the same, the behavior has remained one and the same, and we can very easily we have used it across a console application and Windows application. Now let's look at the web application. Okay, so it's also just the same. So if you go to go here, I have a form, simple form with a bunch of buttons dragged onto the form. Okay, it's taking some time here, so you can see a bunch of buttons. Okay, and then if you go back to the code, for each the click, I have wired up the click event of each button with one line of code, execute sender. What I did is, if you look at here, for each one in tooltip I have added this may not be the best way of doing it, but for simplicity's sake I just added the command name here. So thereby what I'm doing is I will just pass this sender and to an execute method, and inside this executor I just wrote the same 3 lines of code, whereas here I'm extracting the tooltip and passing it to get the respective command. So therefore what happens is, if I now run this command, so you are up and running, your commands are up and running now. Displaying a message box may not be an appropriate it may not be appropriate here, yeah, but my main intention is to demonstrate the logic. Okay, so that is how you can use the same user interface across Windows application or console application or web application. Okay, maybe now this diagram would make more sense to you. And if you look at this, the beauty here is client is not aware of any of the dependencies of the custom command. It's not aware of the dependencies of any of the custom command. It just in fact we have an intermediate presenter class in some UML diagrams. They mention it as an invoker. Yeah, you will have an intermediate class here using which the client will be interacting with all the commands, and that intermediate class called invoker would have the complete knowledge of all the commands that are available in the application, and then you will go ahead and start invoking each of the command that you are interested in, and based on your need you keep extending the validate or execute. From execute, as I said, it's the simplest form. You can go for validate, you can go for undo. So the beauty here is the pattern can be used everything from websites implementing complicated features like undo to implementing simple features like parsing command line arguments in a console application. Generally what happens is if you want to do undo redo operations, you have to encapsulate now by looking at this job lifecycle. I can there are many ways using which I can implement the undo redo operations. I can maybe start noting down or tracking all the command operations and the job IDs in a specific location, and then whenever user calls an undo or redo, I can undo that operation, and or else I can redo the same operation, or else I can go for an exclusive undo method which would do and each command would implement that undo method, and then where in which it will have exclusive access to the area where whenever each commands get executed, it persists that information, and then this method which is implementing undo would have an exclusive access to the repository and gets the data back and recreates the same object, and then performs the undo operation. Okay, so especially where exactly you can where else you can make use of this pattern. This pattern will be, from my personal experience, it will be very useful when you are implementing logging mechanism or validation mechanism or undo redo operations. You definitely need to give a thought about converting those actions into objects by following command pattern. Okay, and and then the other precaution that we need to take care of, the commands must be completely self-contained. So here if you look at the summary, go for command pattern if you really want to decouple the client that executes the command from the command logic and its dependencies. And command pattern is all about representing an action as an object. And if you find the need for supporting undo redo operations, we have to go for command pattern. And if you are implementing validation or logging, then we need to go for command pattern. And in this pattern, using an object, we are representing all the information that is needed to call a method at a later time. Okay, I hope you find this presentation quite useful, and I hope you will use this and implement it in your own applications. See you next time with a different topic. Bye bye.